This puzzle is called Magnetic by rdndnt. I got it from the Sudoku testing submission channel of the CTC Discord. Let's take a look at the rules. So thermometers, digits have to increase as you get away from the circle, aka the bulb. So let's say we found out this was a 4. This digit would have to be a 1, 2, or a 3. This digit would have to be 5, 6, 7, 8, or 9. But that continues down the way, so this digit has to be higher than the previous one, and so on and so on and so on. It's pretty straightforward. Uh, then killer cages, digits in cages sum to the clue in the upper left corner of the cage, and digits can't repeat in a cage. So that's pretty simple as well. So these three digits have to add up to 11. If we found out this was a 4 and a 5, this would have to be a 2, because that adds up to 11. And also digits can't repeat in a cage, so under normal rules, without the killer cage here, these two digits could be the same, but because they're in the same cage here, they can't repeat. So we couldn't do like 3, 2, 3, even though that adds up to 8. I don't know how difficult this is. I think rdndnt usually, I think, has puzzles around 2 out of 5 difficulty, give or take a little bit. I think they have done a couple 3 out of 5s, but yeah, I don't know. I think you'll have to judge by the length of the video. I'll put the link to the puzzle in the description down below, so you can give it a try. Let's get started. So, yeah, I think the thermos are the place to start. 1, 2, 3, 4, 5, 6, 7, 8. So this is the minimums all the way along. So then we have 1 digit of leeway along this thermo, and I think it'll probably be the same along here. So let's just fill it in like that. So we have a 1, 2 pair in here, for whatever that's worth. Yeah, I'm not sure. And I guess an 8, 9 pair looking upwards. So what's important to note here is that these are both going to be fully consecutive lines. So let's say that this was a 1. We couldn't then say necessarily that this is a 2 or a 3 in most cases, because both 2 and 3 are greater than it. But this 1 is going to look over at this other thermometer, make this a 2, make it, maximums all the way up. This 9 is going to look over at this 8, and then it's going to make it minimums all the way along. So obviously we don't know which line is the maximum, we don't know which line is the minimum, but the point is one of them is going to be all maximums, one of them is going to be all minimums. Which I don't know how that'll come into play, honestly, but I think it's going to be good to notice. These 8s, there are only 2 ways of making 8 in 3 cells. There's 1, 2, 5 and 1, 3, 4. Yeah, I'm not sure how to do that either. I guess one of these is always going to be a 2. One of these is always going to be a 3. So we can't, maybe, whoops. Maybe the 11 cage is where we need to look. We need an 11 triple, or triplet that adds to 11, without a 4, 5, or a 6, and the same is going to be true for over here. 11s. Actually, I can actually put these up on screen, can't I? Why is it, there we go. And then I have to click here, there we go. I'm still getting a little bit used to OBS and using it in like real time, so to speak. Oh my gosh, that's really small. Okay, let's make it so you guys can actually see what I'm typing. Okay, so these are the triplets that add to 11, and we can't have a 4, a 5, or a 6. So we're always going to have a 1. And it's either 1, 2, 8, or 1, 3, 7. So interestingly, whichever side is the maximum, let's say this is the minimum, then this will be like this. So we'll have to do, I think, actually, wait, no, maybe both sides need to be 1, 2, 8. I was going to say that one side is going to be 1, 3, 7 and the other side is going to be 1, 2, 8, but if this is the minimum, the 3 rules out 1, 3, 7 from here. And if this is the maximum, the 7 rules out 1, 3, 7. So I think we're just always 1, 2, 8. Okay, that's interesting. 1, 2, 8. Oh, and yeah, I guess we could have done this almost immediately. Where can the 9 go? Uh, in box 7 and box 3 both. It's ruled out of the very corner by this given 9 down here. Okay. Um, one thing we can do is reduce the options for 2 in box 1. So we have, I don't know what to call this. It's sort of, it behaves something like an X-Wing. So in the final puzzle, how many 2s are we going to have in column 2 and column 3? Well, we have 1 2 per column because it has the digits 1 to 9 once exactly. So in column 2, we're going to have 1 2. In column 3, we're going to have 1 2. Well, in box 4 here, we've already said this 2 must be in column 2 or 3. Same for, let's actually change this color. Uh, Same in pink. There must be a 2 in pink. 1 in yellow, 1 in pink. So that should be all the 2s for columns 2 and 3. We can't put another 2. If we tried to put a 2 here, let's say, then in yellow, this will be a 2, and then in pink, this will also be a 2, which, of course, is a problem. So none of gray can be a 2. So where does 2 go in box 1? It must go up here. Actually, we can do this a similar thing, and again, I don't know how helpful this is, but it's something I'm noticing, so we'll just go with it. In rows 2 and 3, we've kind of claimed the 2 2s that are going to go in these 2 columns. One needs to go in yellow, one needs to go in pink. We can't fit another 2 in row 2 or 3. Again, if we put a 2 here, we have to put a 2 here, and then one of these 2 will be a 2, but we've already put a 2 in that row. So in box 2, 2 is going to go across the top somewhere. Okay? So what is this cell? Actually, what are these corner cells going to be? I think they must be 3, 7. As we said at the beginning, these are going to be consecutive lines. So this is either going to be 3, 4, 5, 6, in which case this is a 7, or this is going to be 4, 5, 6, 7, in which case this is going to be a 3. So the very corner, whoops, the very corners are going to be 3, 7. Okay. Oh, okay, so we have actually on both sides, we have a 1, 2, 8 triple, in column 3 and in column 7 over here. So 8 must be in one of these two, 8 must be in one of these two. Neither of these can be 8s. I guess one of these must be a 9, because we can't put a 9 in an 8 cage, of course. And we can't put the 9 any lower because we have these 9s looking over. Okay, well this can theoretically be 1, 2, 3, 4, 5, but we have this 1, 2, 8 triple, so this can't be a 1 or a 2. We do need a 1 in this. One of these must be a 1. We do need a 1 in here. Okay, what about over here? I think it's going to be the same situation. This can't, because of this triple, this can't be 1 or 2, so one of these is going to be a 1. That doesn't necessarily mean one of these two is a 1, because we could, I think, at least at first, no, we couldn't, I guess. We couldn't make both of these 1, for whatever that's worth, because that will make this 1 and this 1, which makes both of these 2. Okay, so for what it's worth, one of these two is going to be a 1. Okay. One of these is an 8, one of these is an 8. Can we... Well, I guess we can do a similar thing, yeah, with 8s here. Again, I don't know how helpful this is, but this keeps coming up, so I feel like it's going to be important. Whoops. In rows 7 and 8, we already have kind of claimed our 2 8s. One in yellow, one in pink, so we can't put another 8 over here in gray. So in box 9, we need to put our 8 down there, which is going to be placed. Oh, that's actually helpful. For some reason, I was thinking the 8s were horizontal rather than vertical. This can't be an 8 because we have an 8 right here, of course. So this is just an 8. Um, and I think the same thing's going to happen in rows 2 and 3. Oops. I keep forgetting that I want to do these different colors. And also miss clicking my mouse. So again, in row 2 and 3, we've kind of claimed our 2 8s, in one in yellow, one in pink. So in box 1, we can't put an 8 in gray, and we also can't put an 8, obviously, on top of the 1 or in this spot because of the 8s looking upwards, so this is an 8. So that would put an 8, I think, along here. I don't know if that's really helpful. I did mark it over here with the 2s, but yeah, I'm not sure. Oh, okay. I think this is something we're supposed to be noticing. So, where can 1 go in box 9? Um, we have this triple here. Let me just highlight this. This 1, 2, 8 triple. So where can 1 go in box 9? It can't go in column 7 because of the triple, and it can't go down there, of course. So we're going to put it in one of these 4 spots. Doesn't matter exactly where, but one of these 4 spots is going to be a 1. And we'll just mark that real quick. And then over here in box 7, we're going to have 1, 2, 8 locked into this cage. So again, the same kind of pattern that we've been looking for this whole puzzle. 1s are locked in up here, 1s are locked in over here. So can this ever be a 1? If we try to make this a 1, which we said one of these 2 cells in this 8 cage must be a 1. So if we made this a 1, then this would be a 1, and then we would have nowhere to put a 1 in yellow, which means nowhere to put it in box 9 at all. So this can't be a 1, this must be a 1. Which makes this not a 1, and makes this a 1. And then also, in box 8, where can 1 go? It must go here, because that's the only spot left. We can't go gray, we can't go here because of here, or any of these. So let's get rid of those colors really quickly. And this 1 is going to be huge. Makes this a 2, makes this an 8, makes this a 1, which makes this a 2, and finally defines which one is going to be the minimum and which one is going to be the maximum. And actually we can do the corners as well. Wasn't thinking about that right away. This one looks down. Oh, for a second I thought for some reason that this was going to become a 2 based on this 1, and obviously that's wrong, but that would have broken the puzzle, which would have been unfortunate because I feel like I'm on the right track here. So this 8 cage can't be a 1, 3, 4. That was one of the 2 options. If you recall, the 2 options are, whoops, 1, 3, 4 and 1, 2, 5. So, oh, I've been just leaving this notepad up here. Haven't really needed it. Whoops. Yeah, we can't do 1, 3, 4 because that would put a 3 in one of these 2 cages. There's a 3 looking over. So it must be 1, 2, 5. 2 can't go here, so this is 1, 2, 5. Kind of similarly, but oppositely, this 8 cage over here can't have a 2 in it because we have 2s. Whoops, we have 2s looking into the cage everywhere. So this can't be 1, 2, 5. This must be 1, 3, 4. I don't... Oh, no, there is a 3 right here. I was going to say I don't see a way to figure that out, but, you know, that's fixed. Let's get rid of Notepad now that we don't need it. We have no more cages, so we don't have to worry about that. Oh, we have a 2 here, looking over at these 2 pencil marks. So with these 3 2s, we can put a 2 here. We can't figure out this quite yet. That's fine. Neither of these can be 1 because of this 1 over here. Let's see, we have a lot of 1s. Yeah, so this must be a 1 over here, which is going to place the final 1 in the grid. Okay, let's look at 2s. We have a ton of 2s. One of these is a 2. Oh, this 2 is actually placed. And so this is not a 2, this is a 2. Which puts the 2 here. I believe that was the final 2. Yeah, great. Okay, where can 9 go in this column? Or an easier way, perhaps, for some people, is just to see these 2 9s looking into box 6. And 9 can't be in column 7, sorry, column 8 or 9. So this is just a 9. Same with this box over here. We have 9s looking in, so this is a 9. Which we had the pencil mark there. Didn't notice that until just now that I've taken the spots of the pencil marks. So what are these 3 digits? I guess this is a naked single, but we don't have to care about that for the moment. Easier way is just to say this column needs a 3, 4, 6, and then this column over here needs a 6, 5, 6, 5, and 7, and of course 6 is the only digit that's in, in both sets, 3, 4, 6, and 5, 6, 7, so this must be the 6. This 4 disambiguates this, and this 5 up here figures this out. This cell must be a 3. What's left is a 5 and a 6. Here we need a digit less than a 5. Sorry, less than a 6, because we have a 6 there. And it can't be a 1, 2, or 3, so it must be a 4 or a 5. Okay, let's just keep doing Sudoku. What's left in this column is a 6 and an 8. And here is a 7 and a 4. That's not resolved either. Huh, okay. What about this box? This is pretty constrained, I think. 1, 2, 3. That's not super helpful. What, 4 is locked into one of those two. 5 up the... No, 6. Not quite. 7. Oh, 7. There we go. 7 was the right question to ask. So 7 goes there, which took a place of one of the 4 pencil marks. So that can kind of remind us that 4 is restricted in the box. And this must be a 4, which makes this a 5, 6. Oh, I was going to say the 5 looks over here, but it does not look over there. It looks over to the left. 5's along here. We need a 5 along here, not in the middle. What's left in these 3 is 3, 5, and 6. We have a 3, 6 here, so this is a 5. So this can't be a 5, this is the 5. We have a 3, 6 pair. Oh, here's just a free digit. This is just a 7. It's the last one in the column. This is a... What is this, an 8, 9? Yep, that's good. This is a freebie. This is just a 9. We have a 9 here, and 9 here, making this a 9. In the column, we have a 6 and an 8. We need a 6 and an 8, I should say. And there's an 8 right here, so this is a 6, this is an 8, which figures this out over here. It looks like it's just finishing up the puzzle. One of these is a 4. What's here? 6 and 3. 4, 7. There's a 6 right here. So this is a 6, 3. This is a 7, which is going to figure this out. Place the 4, and then place the 3. There we go. That was actually probably on the easier side of 2. Probably like 1.5. It kind of depends on how comfortable you are spotting that same pattern that we had, where we would restrict or kind of claim the digits in 2 rows or 2 columns, which would force that digit down into another area. Yeah, that was used a number of times in this puzzle. I don't know how many times it was required. I think it was probably required for the 1s over here, because that kind of broke the puzzle open when we noticed that 1s were restricted into these areas. And ruled 1 out of here. Yeah, I'm not sure. It was needed at least once, but I managed to spot it like half a dozen times or something. But yeah, that was a fun puzzle. And definitely a fun puzzle. And I like the magnets. I didn't actually catch that until literally this exact second, that these were magnets and the puzzle's called magnetic. But yeah, thank you rdndnt for the puzzle, and thank you all for watching.